Good morning, dear students, and welcome back to our online class. We are studying about Charles' law, and in our earlier class, with the help of a video, we came to know about the law which tells us about the relation between temperature and volume of gases at a constant pressure. So today we are going to revise that law which tells us the relation between temperature and volume, that is Charles' law, and learn how to solve numericals based on Charles' law. So let us start out today's class. Charles' law. It states that volume of a given mass of dry gas is directly proportional to its absolute temperature if the pressure remains constant. Here there are three key points, and they are volume, directly proportional, and absolute temperature. So a volume of a dry gas is directly proportional to its absolute temperature, and the thing which remains constant is pressure. So every time when the pressure remains constant, volume and absolute temperature, they relate to each other, and that relation is given by Charles' law. Say suppose the volume is represented by V1 and temperature by T1. Then according to Charles' law, volume is directly proportional to T1. V1 is directly proportional to T1. This means that if the temperature is doubled, the volume would be doubled. If the temperature is tripled, the volume would be tripled. If the temperature is reduced to half, then the volume would also be reduced to half. So whatever we do with the volume, same thing will be done with the temperature. That will be reflected in temperature. If temperature is increased, volume will be increased. If temperature is decreased, volume will be decreased. Now, if we continue from the above proportionality equation, that V1 is directly proportional to T1. Now, in order to remove the proportionality, we use equal to sign and we use constant K. So V1 is equal to K into T1, where K is a constant. Or if we rearrange this, then we get V1 divided by T1 is equal to K. That is, volume divided by temperature is a constant. In the same way, if we take another volume at another temperature, V2 and T2, then the volume divided by temperature, V2 by T2, will be also a constant. That means whenever we divide volume by temperature at constant pressure, we always get the same value, which is a constant. Therefore, we can say that V1 by T1 is equal to V2 by T2, which is constant. So this is the relation which is used to solve different numericals based on Charles' law. Now let us see the significance of Charles' law. What does this Charles' law tells us? What information does it give us? Charles' law tells us that the density of a given mass of gas decreases with the increase in temperature, and vice versa. Vice versa means if the density increases with the decrease in temperature. This is because when the temperature is increased, now volume also increases, but the number of particles in that particular volume remains same. What will happen? The particles will now be separated from each other due to increase in volume. Therefore, density decreases with the increase in temperature. Whereas when the temperature is decreased, the volume also decreases, due to which the same number of particles comes closer to each other. Hence, density increases. This is why to raise the air balloons we need to heat the air so that density decreases, and lesser the density of the gas, lighter the gas will be. Hence, due to decrease in density, the gas inside the balloon becomes lighter than the air which is outside the balloon. As a result, the balloon rises. And in order to bring the air balloon down to the ground, what do we have to do? We have to stop hitting the air inside the balloon, so that again the volume of air decreases, due to which density increases, as a result of which the air inside the balloon now becomes denser and heavier, and as a result the balloon slowly comes down to the ground. So with the help of Charles' law, we can do numerous various things in our life related to gases. Okay, boys? So now let us try to learn how to solve numericals based on Charles' law. Let's say question number 1. 120 centimeter cube of a gas is taken at 27.3 Kelvin. This is an absolute scale. The temperature is then raised to 0 degrees Celsius. What is the new volume of the gas? The pressure is kept constant. So whenever pressure is kept constant, it is a Charles' law. Over here we need to take care of two things, that is temperature in absolute scale, which is 27.3 Kelvin, and temperature at centigrade scale. So let us start solving this numerical. So first let us take the given things. Initial volume V1 is 120 centimeter cube, which is given over here. When volume is 120 centimeter cube, initial temperature is 27.3 Kelvin. These are the initial conditions. Now let us go to final conditions. Now we are asked to find the final volume, so V2 we have to find out. Now what happens to T2? What is the value of T2? Now over here it is given that the temperature is raised to 0 degrees Celsius. This is a different scale, centigrade scale. But remember, when we solve numericals, we always solve using absolute scale, that is Kelvin scale. We do not use centigrade scale or Fahrenheit scale. Okay, so we need to convert the 0 degrees Celsius to Kelvin scale. So we know that 0 degrees Celsius is equal to 273 Kelvin. So our final temperature T2 is 273 Kelvin. Now by Charles' law, we know that V1 by T1 is equal to V2 by T2, which is a constant. Now we need to find V2, therefore when we rearrange, we get V2 equals to V1 into T2 divided by T1. Now when we apply the values, substitute the values of V1, T2 and T1, we get this, that is 120 into 273, which is T2, divided by T1 is 27.3. Now when we solve this, we get a value of 1200 centimeter cube. So we can conclude that the required volume is 1200 centimeter cube. So always remember, when the temperatures are given in different scale, we have to bring that in one scale, and that is absolute scale or Kelvin scale. Let's go to another question, numerical. Question number 2. At what temperature will 500 centimeter cube, that is centimeter cube, of a gas measured at 20 degrees Celsius occupy half its volume? The pressure is kept constant. Again, the pressure is kept constant, so which law we have to apply? Charles' law. Now let us start solving this. Now let's first write down the initial conditions. Initial volume V1. V1 is 500 centimeter cube. This one 500 centimeter cube, and at this condition the temperature is 20 degrees Celsius or centigrade. Now we have to convert this into Kelvin or absolute scale, and how do we do that? by adding 273 to 20. So 273 plus 20 comes to around 293 Kelvin. So this is our initial temperature. Now we are asked to find final temperature when the final volume becomes 250. How do we get this 250? Because it is given in the question that the volume becomes half. So half of 500 is 250 centimeter cube. Now by Charles law, we know that V1 by T1 is equal to V2 by T2. And we are asked to find final temperature T2. So when we rearrange, we get T2 equals to V2 into T1 divided by V1. Now when we substitute the values of final volume, initial temperature and initial volume, we get 250 into 293 divided by 500. And when we solve this, we get 146.5 degree Kelvin. Now since the temperature in the question is given in centigrade scale, so we can convert this Kelvin scale into a centigrade scale. And how do we do that? We need to subtract 273 from 146.5 Kelvin. So therefore the required temperature is 146.5 minus 273 equals to minus 126.5 degrees Celsius. So if the question contains temperature in centigrade scale, then to solve the numerical we have to convert that into Kelvin scale. And finally again, when we write the final answer, we have to convert that derived calculated Kelvin scale, Kelvin temperature into Celsius scale. Is that clear, boys? So this is how we solve numericals based on Charles' law, which is almost same as solving Boyle's law. The only thing which we have to note down is in Boyle's law we have the relation between volume and pressure when temperature is kept constant. So instead of V and T, we have V and P in solving Boyle's law numericals. Whereas in Charles' law, instead of P, we have T and they are related directly. So V by T will be used while solving numerical, whereas in Boyle's law, V into P is used in solving numericals. So based on today's learning, you have an assignment number 2, where you have to solve 2 numericals and their answers are also provided so that you can check your progress. Please complete your today's assignment and submit it on time. Till we meet next time, stay safe and do all things well.